Now let us see some properties of linear transformation. First property, suppose T is a mapping from V to W, V to W. Suppose it is a linear transformation. Then we have to show that T of 0 is equal to 0 dash. And that means we have two vector spaces here, namely V and W, and transformation is T from V to W. Suppose 0 is an element in V, then suppose 0 dash is an element in W, or in general say X is an element here, then X dash will be an element, or in other words we can say um, X belongs to V, then what Tx belongs to W. It should be like that. So that means what is X dash? X dash will be some Tx, and 0 dash will be some T0. That means it sounds like this question is very obvious. This identity seems to be obvious, but uh, we should know what is the working principle behind it, or we have to show it. Okay. In fact, the proof is very simple. It starts like this. We know that this line, for any vector x, for any vector x belongs to V, we have x plus 0 equal to x itself, because 0 is additive identity of vector V. So this line is correct. Now taking linear transformation both side, so we multiply T both side here. In this equation we multiply T both side. Then from here we are getting Tx plus T0. So Tx plus T0. So how it is coming? Because we have already mentioned that T is a linear transformation. If T is a linear transformation, then we should have this identity alpha x plus beta y equals to T of alpha of Tx plus beta of Ty. So this should be satisfied by T, because T is a linear transformation. So here in this case, T of x plus 0, that means here in this case alpha is 1 and beta is also what? Beta is also, so alpha is 1 here, beta is also 1 here, that's why 1 na? So instead of writing 1, we can simply write T. So what is here? X plus, instead of writing beta as 1, we write simply T. Y is 0, y is 0 here, Ty, that's why this, and Tx is x dash, so it is just change of notation, that's why. Now so we know that Tx is replaced by x dash, just we have discussed above, and so we just take T0 as T0, same, and this side Tx is replaced by x dash, and now so here we have added extra 0 dash. Why it is so? Why we can add 0 dash? Because x dash belongs to, so we had a transformation from V to W where x dash belongs to W, but W is a vector space, and 0 dash also belong to, 0 dash also belongs to W, which is the additive identity. So any vector x dash plus 0 vector 0 dash equal to x itself, that's why we can add 0 dash here. Okay, now in this equation, if we compare the quantities both side, here is x dash, here is also a So here is x dash left hand side, and right hand side also we have x dash. Now these two quantities are same and we can cancel. Why we can cancel? Because this x dash belongs to vector space W, and W must be an abelian group. So if it is an abelian group, there exists additive inverse. If x exists, minus x also exists. So that's why we can do the cancellation. So that's why um, it gets cancelled, because we know x plus minus x will give us zero vector, na? Zero vector. That's why this the same quantity get cancelled, and ultimately we are left with this t0, and here this side 0 dash. So first property is proved, and now let us take second property. So we have to prove this. Property. Okay, now we start with the left hand side, t of minus x. So t of minus x can be written as t of minus 1 into x, and minus 1 is this. Minus 1 is a scalar quantity, so scalar quantity we can take out of t से बाहर ले सकता है, क्योंकि ये तो स्केलर क्वांटिटी है. सो इनफैक्ट ये अल्फ़ा का प्लेस में -1 आ गया, इसलिए इसको t से बाहर ले लिया. ठीक है, और -1 मीन्स 1 को गायब कर दिया. ठीक है, 1 इज हियर एंड हियर, so it is simply minus dx. So this is second property which is proved. Again, now we have to show this third identity. So we have to check this one, t of x minus y. So this can be written as t of x plus minus y. So it is simple. And since t is a linear transformation, we can write t of x, this plus, and t of minus y, this minus y, t of minus y. So which is equal to t of x as it is, and so this is, we know t of minus y will be minus of ty, as we have seen above. Okay, that's why from here it will be t of x plus minus t of y. So this is plus minus, it will be t of x minus t of y, which is this one. So it is proved. Okay, so these are some simple properties that I wanted to discuss. So we'll stop here. Okay.